Hi, this is Mrs. Dorman. We're going to solve more power and radical equations. So we're going to look at number 1. What you should do is write these problems down, try them on your own, pause the video, try them on your own, and then play the video and see how you did. Okay, so for the first one, number 1, we want to solve for x for all of these. We want to isolate x. We're trying to get that variable by itself. So we're trying to undo the other operations that are being done to x. So we don't want that 5 in the front. We're going to subtract 5. That's how we're going to start out. Subtract 5 from both sides. Then we have negative 7x squared equals negative 119. Now x squared is being multiplied to the negative 7. We're basically trying to get the x squared part by itself so that we could take the square root of both sides. So I'm going to divide by negative 7 because it's being multiplied by negative 7. And then we'll get x squared equals 17. So now I want to undo the squared. I have x squared equals 17, but I don't want x squared, I just want x. And the inverse of squaring is taking a square root. So I'm going to take the square root of both sides. When you take a square root of something squared, those operations cancel out. And now I just have x, which was my goal, to isolate x. Whenever we take a square root when we're solving, we don't know if the original number was positive or negative, so we put plus or minus square root of 17. So anytime you're solving and you're taking a square root or any even root, a 4th root, a 6th root, we put a plus or minus in front. Because, so if I just go back one step and I plug in positive square root of 17 and square it, that should equal 17. Because if you take a square root and square it, they cancel each other out. We get 17. Or if I plug in negative square root of 17 and square it, I still get positive 17 because when you square a negative, that means you have a negative times a negative. You just get positive. So we don't know if the original number was positive or negative. When we're taking a square root, we put a plus or minus in front of our answer. Okay, we're going to look at number 2, and I see there's a cubed being done to the x. There's an x minus 10 cubed, and then that's being multiplied by negative 1/2. So we're going to have to take a cube root eventually, but first, we don't want the negative 1/2. We want to divide by negative 1/2, which is the same thing as multiplying by negative 2. So then if we do negative 32 times negative 2, we get 64, and then equals x minus 10 cubed. So now I can take the cube root of both sides to cancel out the cubed. Those are inverses of each other. Cube root of 64 is just 4. And then on the other side, we canceled out the cube root and cube cancel each other out, and we just get x minus 10. And then now we can add 10 to both sides, and we get 14. Okay, and we're going to look at number 3. This one has a fraction for an exponent. That's also called a rational exponent because rational means like a fraction, a ratio. So before we can undo the exponent, we don't want the minus 8 there. We're going to add 8 to both sides. Okay, so there's 2 parts to this exponent. When it says to the 3/2 power, that means part of it is a root and part of it is a power. I'm going to rewrite it as x minus 4. The denominator in the exponent is 2. Whatever the denominator is, that's the root. So it's a square root. Think of there's like an invisible 2 there. That's where the 2 went. And then the 3 is in the numerator, so that's the power. So to the 3/2 power means square root and then cubed. So I'm just rewriting it. And then I need to undo both of those. I need to undo taking the square root, which is squaring, and I need to undo taking the 3rd power, which is taking a cube root. So I'm going to do undoing the 3rd power first. So that I'm going to take the cube root of both sides, and that'll undo to the 3rd power. So now I still have square root, but I don't have the cube there anymore. And then the cube root of 343 means what number do you cube, what number do you multiply to itself 3 times to get 343? And it's 7. And if you're not sure, you could go to your calculator and test numbers. Just use 7 to the 3rd power, and it equals 343. Now I need to undo the square root. So now I could square both sides. That's the inverse of taking a square root. When you square root something and square it, those operations cancel each other out, and we just have x minus 4. 7 squared is 49, and then now we can add 4 to both sides. 49 plus 4 is 53. Okay, we're going to do some more, and remember, just pause, try these problems on your own, pause the video, and then play it, and you can see how you did. So number 4 has a square root in it, and we're going to need to square both sides of the equation to cancel out the square root. But before we do that, we want to isolate the square root part. We just want that by itself in one side. So that means we need to move this x to the other side of the equation. Okay, so now we need to undo the square root. We don't want a square root in our equation, so we're going to square both sides. Be careful when you square x minus 6. It means x minus 6 times another x minus 6. Draw the boxes if you want. So then you're distributing. You have x times x, negative 6 times x, another negative 6 times x, and then a negative 6 times a negative 6. And on the right side, we canceled out the square root, so then we have 15 minus 2x. So now I'm seeing an equation with an x squared term in it and an x term in it. That means we have a quadratic equation. We want it to equal 0. We want to move everything, all the terms gathered to one side. So I'm going to subtract 15 from both sides and add 2x. Okay, so I have x squared minus 10x plus 21. We can factor. So if you have a quadratic equation, you can try factoring, and if that doesn't work, you could use the quadratic formula, but this can be factored. Factoring means we're trying to figure out what two binomials multiply together to get x squared minus 10x plus 21. We need two numbers that multiply to get 21, positive 21, and add to get negative 10x. So that'd be negative 7 and negative 3. And we could just double check. If we do x minus 7 times x minus 3 and distribute everything. So we do get x squared. These would combine together to get minus 10x, and then we have the 21. So I'm just double checking that I factored it correctly. Once you factor, you set each factor equal to 0. So you do x minus 7 equals 0. You get x equals 7. If you do the same thing to the other factor, x minus 3 equals 0. So you set the factors equal to 0, and then you would add 3 to both sides, you would get 3. Because we squared both sides in these kind of equations, we could possibly have an extraneous solution. So we really need to plug our answers back in and double check that 7 and 3 do actually both work. So first I'm going to check x equals 7. So I'm going all the way back to the original equation. And I forgot to plug in the 7 for that first x. Okay, there we go. So I'm just going to simplify both sides. The left side is just negative 6. I'm going to simplify inside the square root for the right side. So 15 minus 2 times 7 is 14. So this is the square root of 15 minus 14, just 1. And square root of 1 is 1. And this looks correct. Negative 6 equals negative 7 plus 1 is negative 6. So plugging in 7 worked. It was a solution. So now I'm going to plug in 3 and see if that works. So I'm just going to go back to the beginning and erase the 7 and make it a 3. So I went back and I'm just replacing the x with a 3. I'm going to simplify and see if it equals what the left side equals, -6. Okay, so square root of 15 minus 2 times 3 is 15 minus 6, which is 9. Square root of 9 is 3. And this doesn't look right. -3 plus 3 is 0. This does not make sense. -6 does not equal 0. So then 3 was an extraneous solution. It doesn't actually work when we plug it back in. And our only answer is 7. If we just left it at x equals 7 and 3, we would be incorrect. We would be saying that 3 is a solution, but it's not actually a solution. Okay, let's do number 5. So we have another one with a power, that's a fraction. We want to get the x to the 4/3 part by itself. So we can undo the 4/3 power. So I'm going to divide by -2. Okay, and then I'm going to rewrite the 4/3 power because that helps me just figure out how to undo the 4/3 power. So 3 is the denominator in the exponent. That means the same thing as cube root. And then 4 is the numerator, we just leave it as the power. So to the 4/3 power means the same thing as cube root and then to the 4th. I like to undo the power first, so I'm going to undo the 4th power. I want to cancel that out by doing a 4th root. So if you have a 4th power and a 4th root, they cancel each other out. I still have cube root of x, and I'll undo the cube root next, but I need to simplify the 4th root of 625. We talked about earlier that when you take an even root, we're going to put a plus or minus in front, so it's only for an even root. And I need to think about what to the 4th power is 625. That's what the 4th root of 625 means, and it would be 5. And again, if you're not sure, just go to your calculator and start doing numbers to the 4th power and see what gives you 625. So 5 to the 4th power is 625. So then the 4th root of 625 is 5, plus or minus 5. And then we want to cube both sides. We want to undo the cube root, and that would be cubing. So when you have a cube root and cube, they cancel each other out. And if I do plus or minus 5 cubed, I get plus or minus 125. Okay, we're going to do one more by graphing. So we don't always have to graph in order to solve. This would be used when we maybe have an equation that's a little more difficult to solve algebraically by hand. We have a cube root on one side and a squared on the other side, and that might make it just a little difficult to try to solve. So we're just going to solve by graphing instead. The way we do that is we graph both sides of the equation. So I'm going to graph just cube root of x plus 4. Cube root of x is the parent function that looks like this. I'm just taking cube root of numbers, like the cube root of 0 is 0 and the cube root of 1 is 1. The next easy number to take the cube root of is 8. You get 2. Cube root of -1 is -1, and cube root of -8 is -2. But then it has a plus 4. It's not just cube root. So these 5 dots that I just did would just be cube root of x. But it has this plus 4, and that means it's shifted to the left 4. So I'm going to just take each of these points and shift them to the left 4. I'm going to erase the old points because those are kind of maybe going to confuse me. And then I'm going to connect those points I just drew. And that's the cube root of x plus 4. Now I'm going to do x plus 2 squared. So if I just graphed x squared, that would look like this. I'm just squaring numbers, like 1 squared is 1, -1 squared is 1, 0 squared is 0. If I plug in 2, 2 squared is 4, and I'll do -2. -2 squared is also 4. Then it has the plus 2. So what I've graphed so far is just x squared, but there's a plus 2 in the parentheses, and that means I need to go to the left 2. I need to shift what I just did to the left 2. And I'm going to erase the green ones so I don't get confused, and I'm going to connect the new red ones. So this would be x plus 2 squared. Okay, I still have to solve. All I did was graph so far. The solutions are where the graphs intersect, where they equal each other, because that's what the equation is saying. It says, when does this cube root of x plus 4 equal x plus 2 squared? So I'm going to put those in green, this point here, and the other one is not an exact point. I'm going to have to estimate right there. We just want the x value of the coordinate. So this coordinate is -3, 1. So x equals -3. We don't want the whole coordinate. The one's the y value. We're not solving for y. We're solving for x. We want to know what x is. So -3. And this other one, I'm going to have to estimate. It looks like about negative point, I'm going to put 0.6. Looks a little further than -1/2. And then up, this part doesn't really matter because we just want the x value. We don't want the y value, but I'll estimate it anyway, maybe like 1.8 for the y value. But again, we just want the x value, so I'm going to put -0.6. We really want to plug those in to double check that we found the correct, we graphed everything correctly, and that we found the correct intersection points. So I'm going to check -3. So I'm going back to the original equation and just plugging -3 in for x. -3 plus 4, so now I'm just simplifying each side as 1. And then -3 plus 2 on this other side is -1. Cube root of 1 is 1, and -1 squared is 1. So yes, that one works. I'm just going to put a little check mark next to that. And then now I want to plug in -0.6. So in place of the x, I'm going to put a -0.6. So I went back. Again, we're always going back to the very original equation, and I'm just replacing the x with a -0.6. So I'm going to simplify inside the square, or the cube root, -0.6 plus 4. And then on the other side, -0.6 plus 2 is 1.4. And now I'm going to need a calculator, so I'm going to go to my calculator and do the cube root of 3.4. If you don't have a cube root button in your calculator, it's the same, cube root is the same thing as to the 1/3 power. So you could also try that, 3.4 to the 1/3 power. So the cube root of 3.4 is about 1.5, and then 1.4 squared is about 1.96. So they're a little off, and I think it's just because the way I estimated, and we're just trying to get as close as possible. I think this is pretty close. I'm going to try -0.7 and see if that would have made a difference. So I'm just going to erase, go back, and put in -0.7 instead. I just want to see if that's a little closer. So I'm going to simplify inside the cube root, -0.7 plus 0.4, 3.3. And then on the other side, -0.7 plus 2 is 1.3. And then again, I'm just going to go to the calculator, do cube root of 3.3. And then 1.3 squared. So these are a little closer now, and I think it's just that I'm trying to estimate, and I think -0.7 is a little closer to -0.6, so I'm going to put -0.7 as the other answer. And we're just estimating based on the graph, so it's a little bit off. That's okay. So my answers, I'm going to rewrite it down here. I had -3. That was perfect. It worked. And about -0.7. Again, we're just estimating the best we can based on the graph. Make sure you plug the answer back in and just double check these two sides are roughly equivalent. So I'm going to say about -0.7 works.